All right, we're going to recreate the chart that we created earlier on the unit circle, and I'm going to have cosine first this time. On that chart I put sine then cosine, but I really should have put cosine then sine, because we know that an ordered pair is xy, and we learned yesterday that x is cosine theta and y is sine theta. And so if we put it in that order, then you could kind of visualize, if you just take the first two, that being the ordered pair of the endpoints of the radius that I'm going to draw in a minute. It's going to be a radius of 1. So we have that in our mind. Okay? Now, let's just begin with an angle in standard position with a radius of 1. And what would we say that that angle measure was that I just drew? Angle measure 0 degrees. Now, when the angle measure is 0 degrees, the radius length that I just made was 1. We're going to make that little circle be 1. So my radius is 1, but what's my x value? 1. And what's my y value? 0. So my x value, let me make myself some more room here. Excuse me, I'll start again. We're wanting the unit circle. We've got x is equal to 1. We've got y is equal to 0. And we have r is equal to 1. Now, we know that sine is what? Sine is y over r. Now, I'm going to do it this way. In trigonometry, they're all positive in quadrant 1. In quadrant 1, all of them are positive, sine, cosine, tangent. In quadrant 2, sine is positive, and sine is what? Y over r. But sine is positive in quadrant 2, and sine is y over r. What's positive in quadrant 3? Tangent. And tangent is y over x. And what's positive in quadrant 4? Cosine, and cosine is x over r. So, if I'm talking about cosine, and see where I've got cosine here. If I'm talking about the cosine of 0 degrees, then I'm talking about x over r, which is 1 over, see, I'm talking about x over r for cosine, which is 1 over 1, which is 1. And cosine of 0 degrees is 1. Now, if I'm talking about sine of 0 is y over r, and 0 divided by 1 is 0. Notice something. What are the coordinates of the endpoints of that angle I just drew with a radius of 1? What's the coordinate of the endpoint? It's 1, 0. See, the coordinate of the endpoint is sine at that place, cosine at that place, sine at that place. See, if I take cosine 0 comma sine 0, I actually have the coordinates of the endpoints of an angle drawn that's 0 degrees and has a radius of 1. You see. All right, now tangent. We know that tangent is I. 0 divided by 1 is 0. So for 0 degrees, cosine is 1, sine is 0, tangent is 0. If we thought of the cosine answer, the sine answer as an ordered pair, it would give us the coordinates of the endpoint of that segment I just drew. Okay? But we still want to memorize. Cosine of 0 is 1. Sine of 0 is 0. Tangent of 0 is 0. We want to memorize that. Okay, now we're going to draw a new radius. This time, we're going to start with the center 0, and we're going to go 30 degrees. Now, when we go 30 degrees, here's what we're thinking. I could drop that down and make a little right triangle, correct? Now, what is the radius of my little right triangle? 1. What kind of a little right triangle is it? 30, 60, 90. See, we're talking about a unit circle. We're talking about the radius being 1 every time. Now, you realize that this, and I'm going to do this in green, do you realize that this vertical distance is actually the y value, which is sine, and this horizontal distance is your x value, which is cosine? Let's think about in a 30, 60, 90, what would those be? What is the relationship in a 30, 60, 90 between the hypotenuse and the short leg? Hypotenuse is twice the short leg, which makes the short leg half the hypotenuse. Now, the way we did this yesterday, we said sine is leg opposite over hypotenuse, and we went to our other ratio. I'll draw one here. We had a 30, 60, 90. And we said in a normal 30, 60, 90, we let the short leg be 1 and the hypotenuse be 2 and the long leg be square root 3. But if we have a unit circle, see, if we have a unit circle where we're letting the radius be 1, then the short leg would be half. And the long leg would be short leg times square root 3. So when we let the radius be 1, my short leg is actually my cosine value, my sine value, excuse me, and my long leg is actually my cosine value. You see, in the unit circle, that's when the radius is 1. And so what is the cosine of 30 degrees? Square root 3 over 2, that horizontal distance, that x value here that we had in red, right? Cosine is square root 3 over 2. What is the sine of 30? Well, it's the vertical distance in my unit circle. It's 1/2. And what is the tangent of 30? Well, if we did this, tangent would be leg opposite 1 over leg adjacent square root 3, and then we would rationalize, and we would get square root 3 over 3, which we talked about yesterday, and so we have square root 3 over 3. But notice this, in reality, if I took my cosine answer, comma, my sine answer, what would that be? It would be the coordinates of that point. You see? An angle in standard position, rotated 30 degrees with a radius of 1. Okay? And that helps you understand how this fits into the unit circle. All right. Now, we're just going to play with some stuff. You've got the whole chart created, so there's no sense in having to create the whole chart, but we want to backtrack some stuff in our mind, and you can get the rest of those things in there. Let's talk about some reference angle stuff. Let's say that we had an angle right here. Let me move it. Didn't go far enough. Missed again. Strike 2. 3 strikes and we start over. Right there. Okay. Each of those are 15 degrees. 2 15s is 30. This is going to be 30 less than 180, which is 150 degrees. What is the reference angle for 150 degrees? It's to the nearest x-axis, 30 degrees. Okay? So let's just talk about that little situation. I'm going to move these back in here. We want cosine, sine, tangent. Now, we're talking about the cosine of 150 degrees. If we want to talk about the cosine of 150, then we really want to think about its reference angle 30. So then we're really going to be asking, what's the cosine of 30? Well, the cosine of 30 is, if you go back over here, it was square root 3 over 2, right? the cosine of 30 degrees was square root 3 over 2. So the cosine of 150 is going to be the same as its reference angle, square root 3 over 2, but we're in quadrant 2, and the only thing positive in quadrant 2 is sine. So cosine is going to be negative square root 3 over 2, because the only thing positive in quadrant 2 is sine. So it has the same value as the reference angle, except we have to look at what quadrant to determine whether it's positive or negative. Okay? You understand that? Let's draw another one. Let's say we had an angle that started there and it ended up over here at 135 degrees. If the angle's 135, then what's its reference angle? Well, from here to the nearest x-axis, which is 180 minus 135, which is 45 degrees. So my reference angle is 45. Now let's just say that we were dealing with sine. So we'd think, well, what's sine 45? Well, we're supposed to have it memorized by today, right? So sine 45 was square root 2 over 2. You got a cheat sheet right in front of you. Use it as long as you can. There'll be a day you can't. Square root 2 over 2. We're going to be memorizing those. So it's square root 2 over 2. We're talking about tangent of 135, whose reference angle is 45, but we're in quadrant 2. And what is positive in quadrant 2? Sine only. So we're talking about tangent, so it's negative square root 2 over 2. When we're talking about tangent. I didn't say tangent. I'm sorry. I said sine, didn't I? I said sine. It's positive. Sorry. Thank you. Tangents. Yeah, tangent is a negative 1. That's correct. So the sine of 45 is square root 2 over 2. Sine is positive in quadrant 2, so it's a positive square root 2 over 2. You'll see how we're using our reference angles. Okay? All right. So let's build some bigger ones. So let's jump down here to let's just go all the way over to here. Now this is 270, and that's 15, and that's another 15, so we're 3070, which is 300 degrees. 300 degrees. Those are zeros. 300 degrees. What is the reference angle for that? To the nearest x-axis, all the way is 360. 360 minus 300 is 60, so my reference angle is 60. Let's just say we're dealing with tangent. So we go to our memory bank. It's got to be there within a few days. What is the tangent of 60? It's square root 3 if we were in quadrant 1, right? The reference angle is 60. Tangent 60 is square root 3. You'll have that memorized. So you'll say square root 3. And then you'll say, okay, what quadrant am I in? 4. What's positive in quadrant 4? Cosine. But we're talking about tangent. So it is negative square root 3. Everybody see how we're using our reference angles? What's positive in which quadrant? And memorizing everything on that chart to be able to do that. Okay? Everybody understand that? Okay. So that gave us a unit circle visual. So now we're going to go to the worksheet. So I'm going to move that. I'm going to pull up some blank Adobe pages, and we're going to work on these problems. Now, what I gave you, it says use the unit circle to find the values of the 6 trigonometric functions. we have sine, cosine, tangent, and then we have cosecant, secant, and cotangent. Did I do too many? Yep. Now, you realize that you need to memorize these. And so hopefully the thing that happens on a test is it's just in your brain. Doom, 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 doom. You know them or you miss them all. Either you know them or you miss them. So this is kind of like one of those 100 or zeros, except you have a graphing calculator that you can use, which I'll show you how to use. But you'll have a test like this one day, and I won't let you use the calculator. We're just going to give you a little bit of time before we do that, to give you some time to memorize. So know that eventually you're going to have one of these, and you just have to pop the answers out of your brain, straight out. Sine of 30 is 1/2. The sine of cosine of 30 is square root 3 over 2. It's going to be memory work. Tangent 3, square root 3 over 3. The cosecant, now these you're not going to memorize. You're going to know your reciprocal functions, right? Cosecant is reciprocal of which one? Sine. You just have to memorize that. Cosecant is reciprocal of sine. Sine's 1/2. What's reciprocal of 1/2? 2 over 1, so cosecant is 2. Secant is reciprocal of cosine. If cosine 30 square root 3 over 2, then secant 30 is 2 over root 3, but we don't leave it like that. We have to rationalize, and so we're going to get 2 square root 3 over 3 for secant 30. So we memorize sine, cosine, tangent, and then we know which one's the reciprocal of which one. Understand that? Okay? The cotangent. What is the cotangent the reciprocal of? Tangent. So if tangent was square root 3 over 3, then cotangent would be its reciprocal 3 over square root 3. But you can't have a radical in the denominator, and so you have to rationalize, which gives you 3 square root 3 over 3. You understand the 3 on the bottom, right? And then the 3's cancel, and you get square root 3. So you're going to have to do a little bit of rationalizing after you do the reciprocals. Everybody see how we got that? Now that's supposed to happen without a calculator. You're supposed to just be able to go in your brain and do it. I need to show you how to use the calculator because as you move on into trig, you're going to use it for some things. And as you move into calculus, you're going to use it for some things. But these 30, 60, 90, 45s and all, it's better if you can do them out of your head. So we just need to know them also. But we also need to know how to use the technology. So let's use the technology here. The first thing that we need to know when we go to the graphing calculator, and I'm just going to clear mine out, second plus 7, 1, 2, enter, clear. We have degrees and radians. The radians is the stuff with pi attached to it. Okay? The degrees is degrees. The first thing we need to do is make sure we're in the right mode. If you do second plus 7, 1, 2, enter clear, it's going to default to radians. So you need to check it. We're going to hit mode. Pause. Okay, so we're going to hit mode. We're going to arrow down. It would have been on radians, but I've had to do something to the calculator and it went on back. So we're going to arrow down and over to degree, hit enter to make sure it's in degree mode, okay? And then we can hit second mode, which is quit, and that'll put us back to the home screen. So since it's in degree mode, we should be able to just put sine, just hit the sine button, put in the degree 30, sine 30, hit enter, and there's your 0.5. It's going to give it to you as a decimal. As a fraction, it's a half. If you want a fraction, just hit the math button. The first choice is change to a fraction, hit enter, and there it is. In pre-cal, we shouldn't have to do that. We ought to just know, right? Now, watch what happens here. Watch when I do cosine 30. When I do cosine 30, is it going to give me square root 3 over 2? No. And that's not going to be acceptable. If on your test you put .866, I'll count it wrong. That means even if you have a calculator, you still have to know the ones that have radicals, or you're going to miss them. So you're going to have to start doing your memory work fast. Okay? Now, let's talk about cosecant. This is very important. Everybody listen to this. When you did trigonometry and you wanted to undo sine, I'm just going to write this on the board. If we had sine x degrees is equal to 0.6943, and you wanted to solve for x, you would say, I'm going to undo sine with inverse sine. And so you would do the sine -1, inverse sine. Now listen to this, this is important. The negative on an exponent means what? The negative means the reciprocal of. It does not mean that here. The -1 on a sine, cosine, or tangent function has been assigned to the concept of inverse. Therefore, it does not represent reciprocal. What is the reciprocal of sine? Cosecant. Sine -1 does not mean cosecant, the reciprocal of sine, because it's already been assigned to mean inverse sine. So to get cosecant, there's a couple of choices. You could say 1 over sine theta. That would work, right? 1 divide sine theta. That gives me the reciprocal. Or there is a reciprocal button. The reciprocal button on the calculator is, that's it right there, right? The x to the -1 button, is that the right button? That's the reciprocal button. So let's just see if we can do reciprocal sine 30 and end up with 2, okay? So we're going to do sine 30 degrees, but we want the reciprocal. See if that works. Okay? So to get cosecant, we plugged in sine and said, I want the reciprocal of that. We hit the x -1 button. We hit the reciprocal button. So I don't really want sine 30. I want sine 30's reciprocal. See how we did that? Okay, so that's an important little piece of the puzzle. Okay, any questions on the calculator part of it? All right, now we want to go to the next problem. So I'm going to bring my Adobe page back up if I didn't totally X out of it. That's good. And we're going to look at the bottom. Now on the bottom it says, find the values of 6 trigonometric functions for angle theta in standard position if the point -3,4 lies on its terminal side. Let me draw a picture of that. It says that the point -3,4, where's -3,4? To the left 1, 2, 3, down 1, 2, 3, 4. It's saying that, thank you, +4. So the point -3,4 is right here. If we were to draw the triangle with the radius, there's my right triangle, right? And it has -3, +4 as the coordinates of that point on the terminal side. Let's see what we're doing. Now, what that means is this is 3 units to the left. It's still 3 long. And this is 4 units up. It's still 4 up. If we're going to write sine, cosine, tangent, 28, 29, 30, if we're going to write sine of that angle theta, then we're going to have to think of it as being the y over the r, correct? And we're going to have to think of cosine as being the x over r. And we're going to have to think of tangent as being the y over x. We're going to think of cosecant as being the reciprocal of whatever sine comes out to be. Secant as being the reciprocal of whatever cosine comes out to be. And cotangent being the reciprocal of whatever tangent comes out to be. So on this one, it's not special 30, 60, 45, 90 stuff. It's using the Pythagorean theorem. Remember, what we have created here is a right triangle. The radius is the hypotenuse of that right triangle. This is x, and this is y, because x is your horizontal distance and y is your vertical distance. And by the Pythagorean theorem, we would get that x squared plus y squared is equal to the radius squared, right? X and y are the legs, and the radius is the hypotenuse. So we could use the Pythagorean theorem to get the radius. And so we would have 3 squared plus 4 squared equal radius squared. 9 plus 16 equal radius squared. 25 is equal to radius squared. I heard you just a second. And so then we're going to square root, and we're going to get radius is equal to 5. The question was, what about the negative on the 3? You could put it in there. Yeah, because if you did negative 3 quantity square, you still have a positive 9, right? If you think of it visually as the horizontal distance, you could think of it as a positive 3 if you're visualizing. If you want the actual x value of the coordinate, it really was a negative 3. I was considering in my mind the distance and considering it positive. Either way is fine. When you square it, same deal. Good question, though. Okay, now, the thing is, I want to answer that question again. He asked a very important question that will get us in trouble if we're not careful. He said, what about that negative? Now, the thing is, we really want to ignore the negative. It would be better for you not to. What tells us about positive and negative? A, smart, trig, class. They're all positive in quadrant 1. Sine is positive in quadrant 2. Cosine, a tangent is positive in quadrant 3. Cosine is positive in quadrant 4. Don't even worry about the sign. Just get whole number answers. And then the quadrant's going to tell you if the final answer is positive or negative. Okay? I like to ignore the negative personally. Some people might want you to put it in there. I think it's a distraction. Okay? So I'm thinking distances. Let me show you what I'm talking about. Sine is the y value. Now, let's just make them bigger. X was 3. Y was 4. R was 5. I'm just going to make them bigger. Sine is y, 4, over R, 5. Now, positive or negative? See, we don't have to worry about was the 3, 4, or 5 positive or negative. We want to know what quadrant are we in. We're in quadrant 2. What is positive in quadrant 2? Sine. So the sine answer is positive. It doesn't matter if the 3 or 4 or 5. See, we don't care whether they were positive or negative. We care what quadrant we're in and what is positive in that quadrant. Now when we go to cosine, cosine is x over r. And so cosine is 3 and 5. But then we think, well, what quadrant are we in? 2. Is cosine positive or negative in quadrant 2? It's negative. You see, that tells us the final answer is negative. Doesn't matter if the 3 was negative or the 5 was negative or the 4 was negative. 5's never going to be negative because it's the distance. Let's look at tangent. Tangent is the y, which was 4, over the x, which was 3. Again, we're not caring if one of those is positive or negative. That just makes a mess out of your brain. We think, where are we at? Quadrant 2. What's positive in quadrant 2? Sine only, which means tangent is negative. Because somebody will say, but there wasn't a negative on the 4. The negative was on the 3. Don't do that to yourself. Okay? You don't even want to go there. All right. Now, let's think about then cosecant. Cosecant is reciprocal of sine, so it's going to be 5/4. Now, when you take a reciprocal, does it change the sign? It does not change the sign. So if sine was positive, its reciprocal is positive. Let's talk about the inverse of cosine is what? Secant. So when you reciprocate, you flip it, but you keep the sign the same. If cosine is negative, then its reciprocal, secant, is negative. Okay? Cotangent is the reciprocal of tangent. Tangent was negative 4/3. The reciprocal, you flip it, but you keep the sign the same, negative 3/4. We've covered a lot of stuff in lesson 23 to 25. There's a lot of stuff. But we've gone through the whole worksheet part, and we've got the videos to watch, and they're all available on the internet for you. So, any other questions before we stop here? There's a back page. Yeah, that's right. There's some more problems. That would be a good question. What about 34 through 38? That's good because this gets into something else we needed. Thank you. I was fixing to shut down the video. Okay. Number 34 to 38. It says, suppose that theta is an angle in standard position whose terminal side lies in the given quadrant. For the function, find the remaining 5 trigonometric functions for theta, and it gives us that sine of theta. I'll try again there. It gives us that sine of theta is equal to negative 8/17, and we are in quadrant 4. Now, we want to draw a picture, just so we can say we did. What we've got is we're in quadrant 4. Now, do you realize that negative 8 and 17 doesn't really tell us whether the y was negative or the r was negative or whatever was negative? We've figured that out. But we know that sine is y/r. Now, we do know that. And so, if we're in quadrant 4, that tells us that we went to the right. I got to make more marks, right? I don't have to make more marks. I need to make a whole lot of marks down here, right? So it's y/r. So yeah, we don't know how many to the right. Now, my y is 8, okay? So I've got 1, 2, 3, 4, 5, 6, 7, 8. Right? And my r is 17. See, I just kind of guessed where it was. You understand? Because I don't really know where it is. So I've got a y value of 8, and I've got an r value of 17, and I need to find my x values. Everybody getting a visual of that? Now, we didn't draw it right where it goes because we really don't know right where it goes. So what I'm going to have to do is the Pythagorean theorem. X squared plus y squared is equal to my radius square. And I need my x value. I had sine, which is y/r, so I had my y value, and my r value. You understand what we're doing? Okay? And so we're going to have x, which we don't know, square, plus y, which we know is 8 square, is equal to the radius, which we do know is 17 square. And then we're going to do the exponents, so we're going to have x squared plus 64 is equal to 289. And then we're going to start undoing. We'll undo addition by subtraction, and we'll get x squared is equal to 225. And then we're going to get rid of the square with the square root, and we're going to get x is equal to 15. So I have x equal 15, y equal 8, and r is equal to 17. And I know I'm in quadrant 4, so I ought to be able to answer all the questions. Okay, so we got that. Now, you really don't have to draw a picture in the future. You just have to know that sine gave you what? Sine gave you y and r, and you don't really need the negative, right? So you're just going to plug that into the Pythagorean theorem. You didn't really have to draw a picture. I just wanted you to get a visual of it, you see. Okay, so now if we want sine, what number is that? 34? Did we start with sine? Cosine? We started with cosine. So we said cosine, I gave you sine, that's right. So cosine of theta is going to be x over r, which is 15 over 17. But then we got to think about the positive or negative. What quadrant are we in? 4. What's positive in quadrant 4? Cosine only, so cosine is positive, so it's 15/17 positive. Okay? Number 35. Number 35, we have tangent theta. Tangent is y over x. My y value was 8. My x value, 15. What is it that is positive in quadrant 4? Cosine is positive, therefore tangent is negative. Negative 8/15 for tangent. You see what we're doing? Okay. Number 36. Number 36, we have cosecant. Cosecant is the reciprocal of sine. Cosecant is the reciprocal of sine. So it's the reciprocal of negative 8/17, which is negative 17/8. Remember, when you take the reciprocal, you flip it, but you keep the sign the same. Number 37, we have secant. Secant is reciprocal of cosine. Cosine was 15/17, so secant is 17/15. Flip it, keep the sign. Number 38, we have cotangent. Cotangent is reciprocal of tangent, so we flip it to 15/8 and keep the sign. Any questions on lesson 23 through 25? That's a lot of stuff, We're going to have some work days and then a test, so be prepared. Realize your calculator can't do all this. Your brain has to do it. We have to do memory work before the next test.